Wir kommen zum nächsten Pitch und das ist mit Deep Sea IoT Challenges and Opportunities David Gschwend. Er ist Department Head High Performance System von Supercomputing Systems AG, ein kleiner Zungenbrecher, und Stefan Goranov, General Manager Global Sustainability Solutions von WinGD AG. Herzlich willkommen.
Vielen Dank.
Let us bring you a topic that might be a bit distant from landlocked Switzerland, merchant shipping, and what IoT can bring and what IoT we expect to bring in the near future to that sector. But first, let us shift a bit of the perception of a ship as a big steel piece that is sailing somehow from point A to point B. Actually, the ship is a system composed, a system made by many, many other systems. And the IoT brings the synchron between all those and making it run as one coordinated whole. What WinGD, the company I work with, is focusing is on the energy system. So we are integrating different energy resources, and those being the main engines, shaft generators, auxiliary engines, and we optimize the power management on the vessel. Our key component is the main engine, actually the machinery that is propelling the ship. And to bring you a perspective, our biggest product, which is a 77 megawatts, it's as tall as a 5-story building. What IoT help us to do today is to increase the efficiency by communicating among the systems, by making sure that the ship is in its optimal running stage, given the transient capabilities of different energy resources and other factors. It helps us increase the availability of the vessel and the operational continuity. The data-driven method can extend the times between overhauls of the component and allow precise planning and maintenance of repair works. And of course, greenhouse gas reductions. And this is tightly linked with efficiency, as the greenhouse gas, the CO2 equivalent emitted are proportional on of the fuel burned. And if we optimize the fuel consumption, we are decreasing the greenhouse gas, the eco footprint of the vessel. What we are looking forward that connectivity and IoT brings further is more efficient use of hybrid energy systems and situational-based optimization, meaning that if the ship is sailing through a canal or in a calm weather or in a rough weather, one can alter certain parameters and increase the efficiency. We expect just-in-time shipping to be implemented, meaning that the ship arrives at port when it needs to arrive and not faster. That would cut significantly the fuel consumption. And autonomous shipping is a big topic in our industry. However, we being over 100 years in the shipping industry, we know relatively well what the industry needs, what the requirements are, and what needs to be done. However, we need a partner to guide us through the state-of-the-art technology that would implement our requirements in the most efficient way. And we found SCS, Supercomputing System, as such a partner. We have been working for several years together, and Dave now will explain about the challenges they face fulfilling our requirements.
Thank you, Stefan, and thanks you. So, as Stefan already mentioned, amazing opportunities ahead for the future of shipping. However, there are also some tricky challenges. Here are just 3 out of many. Deep sea is a really rough environment, yet the reliability of these systems on these ships is really crucial. Not only is the engine a safety-critical component, but having the engine running just slightly outside of its ideal operating point suddenly means increased fuel consumption, which can lead to thousands and hundreds of thousands of dollars lost in terms of fuel cost. So monitoring KPIs on such a ship is super important. At the same time, connectivity can be really poor. At least before the widespread availability of Starlink, satellite bandwidth was rather measured in bytes and bits rather than megabytes and gigabytes. So it's crucial to do the conversion of raw data to insight right at the edge on the vessel. And finally, of course, cybersecurity is a huge topic. Cybersecurity on ships means if you get hacked, you can probably have a hijacked gas carrier and not just some database on a server, which can be a real threat to society. Therefore, we need to address these challenges. However, as Stefan already noted, WinGD was facing this classic machine builder dilemma. So many traditional companies have amazing mechanical skills. They have data scientists that know the latest and greatest mathematics. They have great ideas for IoT, but someone needs to bridge this gap between the steel, the machine, and the maths. So this is where supercomputing systems came into play, and together, WinGD and SCS architected a modular, scalable, and super reliable platform that serves as the engine control system for these engines that WinGD builds. It's a tailor-made embedded system from custom hardware all the way up to software and algorithms. Everything is fused together with fully automated testing, and it is certified according to marine norms and cybersecurity norms. This system includes custom hardware that supports hundreds of thousands of sensors. On WinGD's largest motors, we have multiple hundreds of sensors producing data in the rates of tens of kilohertz sampling rate, in total millions of data points per second. We have an FPGA-based real-time control system, which allows highly reliable microsecond accuracy control. We have a powerful computer system for all the at-the-edge processing for IoT connectivity and high-level control. And we have, on top of the custom hardware, a customized Linux operating system that provides really data center-grade cybersecurity. We have, of course, also a lot of software. The embedded software, we call it the foundation, serves as an abstraction layer that translates between the electrical signals and really the domain language of the customer and allows them to have the algorithms run at a very high abstraction level. As an engineering service provider, building such custom solutions is the core competence, is our profession and our passion at Supercomputing Systems. We apply state-of-the-art methodology, and we know the latest technology that fits just right for your application. When you order a product from us, all IP rights go directly to you, as you are the one that is really in charge of building the system. You own your system. Besides that, you get the expertise from 130 passionate engineers, and we bring experience from more than 3,000 successful electronics and software projects. Well, talking experience, to be really honest, we had no idea how to run a diesel engine before we went to WinGD. But that's not really a problem. It's actually an opportunity for a project to get this kind of an outside view of people who still see the individual trees instead of the forest. And I think the key to success, not only in this project, lies really in this collaboration, the synergy from our experiences, having the domain excellence of WinGD, having the technical expertise from SCS, and the result is a reliable, safe, and future-proof IoT system that the engineers love to work with. It's a platform that was built faster, better, and more cost-effective than any one of us could have done on their own. So let us know if you have either a marine or an IoT challenge that we can solve together. We'd be more than happy to talk.
Thank you very much. Impressive use case in an area where most of us don't really have experience in the daily life. And that's also my question. So this is for a very complex business. What other scenario would be possible that maybe are the business of our audience today? Can you do that transfer of other use cases?
Yes, sure. I mean, IoT provides opportunities in almost all kinds of aspects, all kinds of industries all around. That can be a manufacturing plant, that can be someone who really is in the traditional engineering business. it's not about ships. It's really about applying this new technology to traditional industries and making them better, faster, more effective.
And so the effort to customize it to other industries, how big would you estimate that? Because you also mentioned regulations and very specific knowledge for deep sea that you have to build up and cannot scale in other industries.
Yeah, and this is certainly one of the difficulties that we face as an engineering service provider. Basically, each project starts at zero. We have to get to know the domain, we have to get to know the challenges, and we have to build a vision of what should be done and how it could be done together. And this is where working together in a partnership really comes to play. This system in particular is not really built as a platform that would extend to all other industries. It's more learning from the experiences of this project that can bring us further.
Right, if I may add something. Actually, the system that we have developed together is a machinery control system, and we're using it for controlling other applications than the main engine. So it has been done in a relatively modular way and scalable way that the effort of putting another functionality block as an application software is not that high.
It might be a naive question, but like the airline industry, is that also similar or totally different business?
They have a completely different set of regulations and standards. So this is tailored for marine grade, which is probably a bit higher than a land application, certain land application, but for the Navy or aviation, I guess this is a different.
So the marine of my home canton, Bodensee, would that also be enough?
Yes, indeed.
Okay, so we will find solutions, and I hope you will also have interesting discussions in the breaks. Thank you so much for being here.
Thank you.